Hi, this is a screencast for Math 8, Lesson 9.4, Choosing an Appropriate Data Display. Our learning target is that I can choose an appropriate data display. Our vocabulary term is misleading data, and what that means to have a graph that is misleading. Please read pages 394 to 396 and do the 9.4 online practice. So if you go to page 394, there's a really good summary of all different types of data displays. Some of them you might have seen, probably most of them. So if we look at the first two, pictograph and bar graph are really good when you want to compare different categories of things, like you've taken a count and you want to compare how many of something happened or how many of something you have, and you're comparing those by categories. So pictograph has pictures. Okay, the bar graph has bars. A circle graph is when you want to show something that has a whole, like 100%, and then you want to show the different parts. So here you can see in the circle graph, the largest part is green and then yellow. Okay, and you can compare different sizes of the whole circle. Okay, a line graph is something we've done a lot with, and these are good when you show some kind of change over time. So on our x-axis we might have some sort of time value, could be whatever, days, minutes, seconds, and on the y-axis we're counting something else, and we're keeping track of how this whatever it is, this variable changes over time. A histogram is very similar to a bar graph. It counts frequencies, which just means how often something happens. It's a little bit different than a bar graph, but for what we're doing, it's really very similar. Stem and leaf, box and whiskers, we're not going to worry about. A dot plot is the same or very similar to a bar graph. It's just that using dots instead of bars. And then scatter plot is something that we did earlier in this chapter. If we want to compare two variables, we're comparing an x and a y, and we want to see, is there some sort of pattern or correlation that, say, the more of one, the more of the other, or the more of one, the less of the other. Okay, so that's when you want to compare two different variables for a relationship. So one of the skills they want us to have is to be able to choose an appropriate data display given a certain set of data. Here we have the number of students in a marching band each year. So I see the word year is part of this, and year is time. So if we were to make a graph that we put the time on the x-axis and then the number of students on the y-axis, a line graph might be a good choice. Okay, either a line or a bar graph that would represent the change over time. Let's see what they say. A line graph shows change over time. Okay, on this next one we want to compare people's shoe sizes and their heights. Here I see two different things that are being compared to try to find some sort of relationship or correlation. So if we were to make a graph and put shoe size on the x-axis and height on the y-axis, we could probably plot some data that would show that the bigger the shoe size, the taller the person. So a scatter plot would be a really good choice to represent that data. Okay, again, identifying if a graph is appropriate display for data. Here we are recording the number of hits for our school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits changed during the 5 months. Okay, now that's key. How did this change over time? So here's our data. We've got the number of visits here, and we've got the time units here, the months. There's a couple things that are really good about this graph here. Number one is that it starts at 0 and it goes up by some fixed intervals every 200 number of hits. And then on the y-axis we have months that are going in constant increments. So this is a good data display. The other thing that's good about it is that the bars happen to be the same size. They're the same width. Okay, that makes it like we're comparing things that are similar. Okay, when we have bars that are the same width. They're not the same height, but they're the same width. Okay, this is a histogram, and what this is showing is it's counting the number of months where we had 0 to 399 hits, and then how many months were 400 to 799 hits, etc. So this is a good data display. It just doesn't show the change over time. So they're saying, that's what they said here, is that it doesn't show the number of hits, how it changes over time. So this is not a good data display for what we need. Okay, and this one, this is good. This is a line graph. Here we start at 0. We go up by some fixed intervals, and we're going out here at some fixed month intervals and using the line graph to show how it changes. So this is also a good representation. Okay, talking about misleading graphs and misleading data, let's take a look at this graph first, because I think this is a really good graph. So what this graph is showing us is the total revenue. Okay, that's the amount of money that was made in billions of dollars at a box office. Right, this is probably like for movie tickets or something like that. And then here's our time intervals for these years. Notice how it starts at 0 and goes up by some fixed intervals, 2, 4, 6, 8 in billions. Okay, and then our line graph here is showing the change over time. This is a good graph. Okay, now let's look at this one, which is a little bit different. It's the same data, the same numbers, but there's something that's different. Okay, and the thing that's different is that they jump from 0 revenue up to $8 billion with this little squiggly line, which is called a break. Okay, and it represents a break in the increments. So we go from 0 to 8, then 9, then 10. Okay, what that does is that it's almost like zooming in on this part of our graph. Okay, if we zoom in, we can see this representation shows a little bit steeper rise and then a little bit steeper fall and so forth. And it's not that this is wrong, it's just that it could be misleading, because looking at this data, you might say, you might draw some different conclusions. You might say, wow, the revenue really changed a lot from 2005 to 2009. Look at how much it went up here. When actually, if you look at this data, like you step back and you look at the graph that starts at 0, actually it didn't raise all that much. Okay, so that's why this would be misleading. Okay, some more misleading graphs. If we look at this graph, which is sort of like a poll of favorite foods, we might draw the conclusion that hot dogs was really popular and pizza was medium popular, hamburgers was not really very popular at all. Well, if we look at this other representation of the same data, the same numbers, we could draw different conclusions. And the reason for that is, take a look down here at where this graph starts. Okay, if it starts at 950 and goes up to 1,000, it's almost like we're zooming in and we can see that there's a big difference here. But if we zoom out and we we look at the graph starting at 0 and going up to 1,000, okay, these three results weren't all that different. Okay, if we look at this graph, pizza, hot dogs, and hamburgers are about the same popularity. If we look at this graph, it looks like one is a lot more popular, and that's a little bit misleading. Okay, same thing with this graph. Here we have average house price and year. If we look at this, at the data here, it looks like there's a big difference from 1998 to 1999. And we could read the data and see what that difference is. Well, we got this break here, and if we actually start the graph at 0 and go up by a constant increments, 20,000, 40,000, etc., we can see that actually the difference between 1998 and 1999 wasn't all that great. Okay, so that's a little bit misleading. Okay, the last thing they want us to do is well, this is more sort of misleading data. So let's read the instructions here. A volunteer concludes that the number of cans of food and boxes were about the same. So we have cans of food and boxes of food, and they're saying is that they were the same. Is that correct? Well, down here on our graph, we have representation of what each icon means. And if we look over here, we see they get to about the same place out here. Okay, it looks like cans and boxes were about the same. But if you look a little bit more closely, I'm sure that you can see that the can icons are a lot smaller than the box icons. So actually, if we were to count each can icon and do the math and count the box icons and do the math, this actually would not even be close. Okay, we would have a lot more cans than boxes, and it's misleading to represent the data this way so that it looks in the graph visually, it looks like they're about the same. Okay, so that's why they say this graph is really, or this conclusion is really not accurate. Okay, so if you could do lesson 9.4, do the online practice, be sure to turn that in. That's all for this week. Remember, there is no class on Friday, so if you got 9.3 and 9.4 done this week, you are good to go. Thanks, we'll see you later. Bye. Sorry, one more slide. This will be quick. Explain why the data display is misleading. Okay, here we have concert ticket prices of 3 different rock bands. So the first thing that I notice is that there's a break here. So the y-axis is a little bit misleading. The second thing is that the size of the icons is different. So these smaller icons and then these larger icons are actually measuring the same thing. Okay, it shouldn't be that the size of the icon is different. And if you look at this without looking too closely, you might think that this rock band C had much higher ticket prices because their icons are so much bigger. Okay, over here we have company profits in dollars, and then we have a year. So let's look at this. We've got on our y-axis, starts at 0, goes up by constant increments, and then we've got the years going by constant increments. All of that looks good, except that, again, look at the size of the bars. Here we have a skinny bar, and out here we have a really wide bar. And so that could be misleading, because if you're looking at year 5, you might think that the profit of year 5 is a lot bigger than the profit of year 1 because the bars are so much wider, and that's a little bit misleading. Okay, thanks, bye.